In this video, we will talk about how to divide exponents with different powers and different bases. So I have three examples for us to work through here. Let's check out this first example. We have 4 to the third divided by 2 to the fifth. Now, when we're doing these types of problems, we either want the bases to be the same, so this 4 is the base in the numerator, and this 2 is the base in the denominator. We want these bases to be the same, or we want the powers to be the same. So here's a power of 3, and here's a power of 5. So right now we can see that the bases are different and the powers are different. So we want to try to rewrite at least one of these expressions so that we can try to get the same base or the same power. So we'll notice that 4, that's the same as 2 squared. So what we can do is we can rewrite this as 2 squared raised to the power of 3. And then in the denominator we still have 2 to the fifth. Now when we have some number raised to a power and that's raised to another power, we can simplify that expression by just multiplying these two values together. So 2 times 3, that's 6. So really we can write this as 2 to the sixth. And in the denominator we still have 2 to the fifth. Now we haven't changed the value of anything. So 4 to the third, if you punch that into a calculator, you'll find that's 64. And 2 to the sixth, that's also 64. So we haven't changed the value. We've just rewritten it with a different base. And now we'll notice that the bases are the same in the numerator and the denominator. They both have a base of 2. So when we have an expression like this and we're dividing values, all we have to do is take the power in the numerator and subtract the power in the denominator. So we can write our final answer as 2 to the 6 minus 5. So let's write that, 6 minus 5. So 6 minus 5 is 1, so that's just 2 to the 1. And anything to the 1 is just itself, so our final answer is just going to be 2. So 4 to the third divided by 2 to the fifth turns out to be 2. All right, let's try another example. Let's say we have 4 to the fourth divided by 64 squared. So we'll notice the bases are different and the powers are different. So we want to try to at least rewrite one of these expressions so that the base or the power is the same. So one thing that we might notice is that 64, that's the same as 4 times 4 times 4. Or in other words, 4 to the third. That's what 64 is equal to. So if we want, we can rewrite this as, the numerator won't change, we'll say 4 to the fourth divided by this 64, we're going to rewrite it as 4 to the third. So let's say 4 to the third, and remember it's raised to the power of 2, so raised to the power of 2. So again, we said when we have some number raised to a power, raised to another power, we can just multiply these two powers together to simplify the expression. So we get, let's rewrite the numerator, 4 to the fourth divided by 3 times 2, that's 6, so this is really 4 to the sixth. Now, notice that both of these values have the same base. So all we have to do to simplify this expression is take the power in the numerator and subtract the power in the denominator. So this is really 4 to the power of 4 minus 6. So 4 minus 6, that's negative 2. So this is really 4 to the negative 2. Now when we have a negative exponent like this, we can rewrite this as 1 over 4 to the positive version of that exponent. So 4 squared. So 4 squared is 16, so our final answer is going to be written as 1 over 16. So 4 to the fourth divided by 64 squared turns out to be 1/16. All right, let's try one more example. Let's say we have 7 to the sixth divided by 9 to the third. So we'll notice the bases are different and the powers are different. So let's see if we can rewrite one of these values. So we can't really do anything with the 7, but the 9, that's the same as 3 squared. So let's start by writing that, and let's see if it takes us anywhere. So we have 7 to the sixth divided by, let's say, 3 squared, and that's raised to the power of 3. So we'll write a 3 right here. So again, when we have a number raised to a power and then raised to another power, we can just multiply these two values to simplify the expression. So 2 times 3, that's 6. So this is really 3 to the sixth. So let's write that. So the numerator doesn't change, and the denominator we have 3 to the sixth. Now, this example is a little different. We'll notice that the powers are now the exact same value. Now, the rule here is when you have some number raised to a power divided by a different number raised to the same power, so for example, let's call it a to the x divided by b to the x, when these x's are the exact same, you can simplify this expression by writing it like this: a divided by b all raised to the x. So in this example, we can rewrite this as 7 divided by 3, and this whole expression raised to the power that they have in common, which is 6. So 7/3 to the power of 6. So if you want, you can leave this as your final answer. If you were to punch this into a calculator, it would be something along the lines of 161.38409, and it just goes on and on and on. So in this case, it would be okay to leave this as your final answer. So those were just a few examples of how to divide exponents with different powers and different bases.